Hello and welcome to today's webinar, Peeling the Onion tutorial, exploring viable means to perform secure mainframe file transfers, brought to you by Software Diversified Services. My name is Casey Smith, and on behalf of Share Headquarters, I would like to thank you for joining us today. Share is pleased to continue our webinar programming with this informative and educational event. Please note that presentation slides and recording will be available post-webinar at share.org. The presentation slides are also available for download through the GoToWebinar toolbar. Today's presenters are Colin Vandeross, Senior Systems Engineer, Software Diversified Services, and Tim Full, Manager of Tech Services at Software Diversified Services. We encourage you to submit questions throughout the event via the Q&A box on your webinar toolbar. These will be addressed at the end of the presentation. I would like to now turn the webinar over to Deb Hodson for a brief introduction.
Hello everyone. Thank you very much for joining us today for our Peeling the Onion tutorial, where we will be exploring viable means to perform secure mainframe file transfers. This webinar is one of many webinars in our instructional series. Before we get started, let me tell you a little bit about SDS, or Software Diversified Services. We're headquartered in Minneapolis, Minnesota. We have quality mainframe software since 1982. Our expert development and technical support teams are based in Minneapolis. We have over 25 products for ZOS, ZVSE, ZVM, MVS, and distributed platforms. We're proud of the hundreds of organizations worldwide who rely on SDS solutions. We focus our efforts on mainframe security, compliance, network monitoring, and CICS. Our motto is do more with less. We focus our efforts in providing you cost-saving products and legacy replacement tools. Where appropriate, we partner with strategic subject matter experts in the industry who can add expertise and value to the SDS portfolio. We're very proud of the fact that we are winners of several cybersecurity awards. Before we get started with our presentation, let me just tell you quickly about a couple of future events on the horizon. February 27th, we will be providing a webinar on mainframe security and compliance, how to untangle the mess. We'll overview mainframe security compliance strategies and requirements and discuss some solutions that will hopefully help you lessen workload, add security, and simplify compliance. And then for those of you who will be going to the Share Conference in Phoenix, please stop by our booth. We'll be at booth 516 in the Expo. We look forward to meeting our customers, chatting about your requirements, and meeting some of the new folks out there that are interested in some of the SDS solutions. Here's who's going to be presenting today. Let me introduce our team. Tim Full is our Technical Services Manager here at SDS, and he's located in our Minneapolis headquarters. He's going to be discussing peeling the onion of Secure FTP when it comes to the pros and cons of all the different ways to do that. Colin Vandeross, our Senior Systems Engineer, is located in our Atlanta facility. He's going to be demonstrating 5 different file transfer options. And I'm Deb Hodson, the Sales Manager here at SDS, located in the Research Triangle Park, Raleigh area of North Carolina. And I'm doing the introductions and a little bit of the SDS overview. I will stay here for the remainder of the session in case people have questions. And now on to the presentation. I'll hand it over to you, Tim.
Thanks, Deb, and welcome to everyone. Well, I suspect that you've all seen some news story somewhere about data breaches that have occurred, probably within an organization that you may have had a relationship. And so it's becoming a very important aspect that in our everyday life now to make sure that we take appropriate action to protect any privacy data that's under our domain. As a matter of fact, the government has also been trying to make sure that we're using proper best practices by providing regulations to make sure that we're doing that. But it's always best to get back to fundamentals before you get into heavy, complicated security environments. The interesting part about security is that it's rarely convenient. If it were convenient, we really wouldn't have that big of a problem. So really the trick is to find a good balance between good security and convenience, because if it's inconvenient, odds are really pretty good that people are going to try to find a workaround to bypass the inconvenience of using security. And so you may actually have less security than you desire if it's not convenient enough. So really what you need to do is try to find the right solution to answer the real problem you're trying to address. There are several areas of security that can be discussed. We'll talk mainly today about data that's being transmitted over the network, or what I'd call data in motion. We'll also briefly touch on data that needs to be secured both at the originator as well as the destination, calling that data at rest. And then really briefly just touch on data that might need to be released outside of our own security bubble, such as when we're doing off-site backups, or perhaps when we have some hardware that's become obsolete that had some private data on it. We want to just make sure that that data is well protected, even if it's outside our control. With so many different security domains, there's so many things to consider, but even within a specific security domain, there are several options available for the best ways to accomplish the task. We're going to try to go through a few different options for how you might be able to secure your data while the data is in motion or being transmitted to another site. These different options can all be appropriate depending upon the specific needs that you're trying to accomplish. And so we'll try to review several of these different tools and when it is appropriate to use them. It's my goal to try to provide a scenario where some of these solutions would be best used, and we'll just try to kind of review those benefits and when that's appropriate. First, we'll talk about a tool that's been around for a long time, keeping in mind that when that tool was originally put together, the world was a little different without nearly as many security risks that are out there. Good old FTP has been around for several decades now and still has some appropriate uses, but it's becoming a little bit more limited as to when it's appropriate. Then we'll take a look at how there was an attempt to take the good old FTP and make it secure. This is a good solution in certain scenarios, but it's also a little bit difficult depending upon who your partners might be that you're working with. We'll then continue talking about FTP, but adding into a bit of a hybrid with some other technologies that are out there to help secure your data. What we'll talk about is using FTP going over an SSH tunnel and how that might benefit your organization. Next, we'll talk about another technology that's been around for quite a while and actually has been built around the idea of encrypting data when it's being transmitted, but it has been primarily used on the Linux platform, and so it hasn't been as native on all the other platforms, although it is becoming far more common elsewhere as well. We're going to look at a component called SFTP, which is using SSH as its security model, but the SFTP component that is being used for file transfer specifically. So you already have a big investment in FTP and you want to know what's the easiest way to get from point A to point B. When we discuss this with our customers, this is really a significant problem because they've got FTP jobs buried all over the place, and going back and fixing those can be a real problem. So we will discuss an opportunity for converting FTP to SFTP to automatically get the encryption that's necessary and work well with partners that live on the other end of the line. We'll also discuss some other technologies that maybe aren't specifically designed for transferring files as such, but in general are available and will help to provide the encryption necessary between two sites. We'll just briefly touch on VPN and some of the opportunities it might provide. I mentioned that I would also be talking briefly about how you can protect data when it resides at both ends of the communication so that only certain people can see that data. So we'll talk briefly about PGP. And it does play a factor also in when you're transmitting data to make sure that the data stays encrypted. So let's go ahead and simplify this diagram a bit. All right, let's go back to slice 1. Good old FTP. One of the biggest advantages of FTP is that it is already available in so many places. Windows, Unix, Linux, ZOS, you name it, usually comes with FTP ready to go. The client side is always ready to go out of the box, and usually there's a server side that's pre-installed, just waiting for some configuration information. You'll be off and running. Since it's been so readily available for so long, you've all probably had some exposure to FTP. It's pretty simple to use, follows some common protocols we're already familiar with, and has a nice basic syntax for the fundamentals. In addition, since FTP's been around for so long, and no one wants to really be left out, it usually comes with all the appropriate extensions to make it work well on the platform that it's delivered with. For example, the ZOS FTP server and client handle MVS datasets without skipping a beat. EBCDIC to ASCII conversion is ready to go, and even JES support is available for submission of jobs and extraction of reports. But as Colin will demonstrate, FTP doesn't really handle privacy and security very well. FTP is a clear text protocol. Any eavesdropper on the line can see user IDs, passwords, the data files themselves. In a closed, secure environment, that can save a lot of hassles, but that type of inherent guarantee is more the exception than the rule in today's networking environments. To address networking security issues, there have already been lots of precautions taken, such as firewalls. Firewalls are intended to let safe traffic pass while blocking suspect connections. Good plan, but difficult to implement, particularly when it comes to FTP. FTP is a strange protocol because it was designed around having two connections, one for commands, which is the initial pathway, and a second for data when transfers are underway. This diagram gives a basic idea of what a standard active FTP session might look like. The client requests a connection to the server, the command session, and the server opens a data connection as necessary to transfer data between the partners. The FTP protocol was designed around a trusting relationship. Both participants in the communication were oblivious to the rest of the world. But as the world got to be a more open, less safe place, precautions were put in place. A conventional approach was to place a firewall between the intranet and the rest of the world. Those on the inside were trusted, so were given permission to talk to whoever they liked. But those on the outside were not permitted to start the conversation with someone on the inside. That caused a problem for an active FTP session. So what happened was that the initial command connection would work fine, but when a transfer started up, the firewall would block the new connection coming in from the outside. So a passive mode was added to help deal with this security problem. So in passive mode, the client would indicate its intention to the server. If the FTP server was configured to support passive mode, the server would start a listener on an ephemeral port, which is a dynamic port grabbed from a pool of available ports, and pass the port number to the client on the command connection. The client could then initiate the second data connection, and the firewall would allow the transfer to work. Basic firewall setup now worked, but sometimes this basic setup was not as secure as might be desirable. Limiting access to the outside world can be desirable for businesses in many cases. This could cause a problem for the second connection on the ephemeral port, which was not defined as an acceptable port to the firewall. So firewalls were enhanced to sniff the port number being passed on the command connection to provide temporary access from the host to get that data connection working. Okay, so another band-aid was added to fix the boo-boo. But this will become a problem in a moment when we start talking about FTPS. FTP did not make any concession for improved network performance either. Compression was not native to the FTP protocol. There is a Mode Z extension that is available in some implementations, but you can't always count on it being available. FTP also did not provide any application-level checksum to verify the integrity of the data. It relied on the TCP checksum, which provided some minimal checking, but was easily fooled. For example, a transposition of the bytes in a packet could provide an identical checksum, fooling the integrity check. Network reliability has come a long way, but it's still not flawless. If you need to know the data was transmitted accurately, FTP does not provide the level of confidence that you might desire. Colin will show us an example of the potential exposures that standard FTP can cause. Colin?
Thanks, Tim. So Tim spoke about some of the privacy and security issues facing users when using regular FTP. What I would like to do now is to illustrate to you by running a real-time packet trace on an FTP server how the user ID, password, and also user data can be viewed in the payload of a packet trace. So let's get started. This is the FTP server that I'm going to start the packet trace on. And let me begin by initiating a packet trace on the server that is running on one of the STS LPARs. All of the technical information is already filled in for me, so I can just hit the start button at the bottom of my screen, and I'll be able to view this real-time packet trace interactively on my browser. So let's hit the start button, and as you can see, there's no data yet because I have not initiated the logon from my FTP client. So let's do that. I have a FTP client installed on my laptop, and I've customized it to log on to the LPAR where I'm running the packet trace. So let's go to the site manager, and I've called it bcom1 because that's the user ID I'm using for the FTP logon. And here you can see some of the information about this FTP transfer. I'm using FTP, that's the IP address. There's the user ID, and I've already typed in the password, which is not visible on the screen at the moment. So let's hit the connect button, and that'll then log on to the mainframe. So as you can see, I've successfully logged in, and I've also done a directory listing of the user ID bcom1. Let's go back to our packet trace and examine some of these packets. And as you can see, there's a lot of activity. All of the payload, all of the packets was traced between my FTP client and the mainframe. So let me get to the packets, which I would like to point out some of the this information to you. And the first one is on your screen at the moment. Let me highlight that for you. And there you can see the user ID bcom1. So that's the user ID that is being used for this FTP session transfer. The next one shows where we're being prompted for the password. And the next packet, there you can see some of the very sensitive information. There's the password for this test user ID that I'm using for my logon. If we go further down, we're able to see some of the user data, and there you can see the bcom1 directory listing requested, and you can see also some of the other user data that was sent between my FTP client and the FTP mainframe. Okay, so this highlights how the sensitive information can be viewed in a packet trace. As Tim mentioned, there's so many tools available that can capture IP packet trace information, and anyone with a little know-how can access this sensitive information. Tim will be discussing a number of better options available to you to transfer information to your business partners. Tim, back to you.
Thanks, Colin. So as you can see, the clear data can be easily stolen. So what to do? FTP can still be useful when privacy and integrity are less important than easy access. For example, if the data is public knowledge and there is some room for inaccuracy, FTP might make good sense. Since FTP is familiar and already available in most cases, it can be used effectively. You might want to consider its usage whenever what I'd call an anonymous test would be deemed appropriate. First of all, anonymous access would indicate little need for confidentiality and a limited need for accuracy. Second, anonymous also means authentication is not important. Keep in mind that native FTP means not only data, but also user IDs and passwords are being sent in the clear. So anyone sniffing the traffic might be able to get access to information that you might consider confidential. You may also want to use it on the internet because it's already available and well known. But keep in mind that user IDs and passwords are easily sniffed using tools that are freely available on the internet. A quick internet search for data theft by employees might be an eye-opener. Statistics as high as 80% for data theft being perpetrated by employees can easily be found. Intranet or internet, I'd still consider using anonymous test before using FTP. So in the end, too many things are still being done via FTP, and a review of what really is going on is very often the best place to start. FTP over SSL is very similar to native FTP. The syntax is the same and the protocol is the same. With a bit of configuration, encryption can be added to what we've come to know and love. In the ZOS arena, FTPS is already available as part of the base FTP offering you already have installed. They both provide some nice ZOS specific features such as MVS dataset support, JES support, and SMF reporting on some key events. FTPS also accommodates X509 certificates and Kerberos. Services from outside parties such as VeriSign, Equifax, and several other vendors can do the verification work to make sure the person is who they say they are. And since the server and client were designed to work with z/OS, use of RACF keyrings is available for management of certificates. That all sounds great. It has a lot of features you might be looking for. So what's the downside? Well, as I mentioned earlier when we were discussing FTP and firewalls, that encryption adds a bit of a problem to the workaround of passive FTP. Remember how the server passed the port to connect back to the server on the command connection and how the firewall might sniff that to provide temporary dynamic access for the client? Well, now the data on the command connection is encrypted, so the firewall can no longer sniff it. And even though there are FTPS servers and clients available on most platforms, they're not always as likely to be configured and active everywhere. So when does FTPS make good sense? FTP over SSL is a great candidate for transfers between LPARs and a sysplex. Usually there isn't a firewall between them. The data could still be sniffed, however, even if it is over hypersockets, but it's less likely. By using FTPS, you can protect yourself from sniffers. The I-series also is commonly loaded with an FTPS server and client, so that's another good possibility. And it's not uncommon for the Z-series and I-series systems to live close together on so firewalls might not be in play. Other platforms might also have the functionality available, but the further apart the partners are, the more likely there will be firewalls that will be needing to be configured to allow the multi-connection traffic. Let's move on to talking about a different encryption mechanism other than SSL. SSH is a similar technology that can also provide the confidentiality, authentication, and integrity asked for in encryption. And the FTP you already have in place can take easy advantage of the encryption tunnel. It's also much more firewall friendly. An SSH tunnel only requires a single connection, usually on port 22. The connection can actually carry multiple tunnels simultaneously and deals with the multiplexing, getting the right data from each tunnel to the right application. So what happens is the command connection and the data connection are multiplexed in the same SSH encrypted connection. No more secondary connections coming from the wrong side of the firewall. SSH also compresses the data as it encrypts it, so you get the benefit of reduced bandwidth. Of course, the security and savings of bandwidth come at the cost of CPU, but if you have a crypto processor, you might be able to offload to that. New processors also offer compression engines that can greatly improve performance. SSH also has a more sophisticated checksum process that is less likely to be fooled, so you can have more confidence that the network won't corrupt the data without you knowing about it. Another good solution if everything is in place, but this usually requires some coordination between the partners to make sure it's all there. For example, both FTP and SSH are required on both ends. FTP clients are usually there, but servers may not be. Linux and Unix admins have come to rely on SSH and its SFTP subsystem to move files around. They regularly do not have an FTP server running. First, there might not have been any need for it before. And second, FTP would require another port to be opened up. That opens up another potential exposure to an intruder. This can be a good solution though if all the pieces are in place. You can leverage that which is already implemented in your environment with little to no modifications of the batch jobs. In some cases though, you'll find resistance to loading a back-end FTP server on the partner's platform. So you may need to implement a vanilla SFTP transfer. Before we go on, I'd like to clarify a bit about SFTP. SFTP is not the encryption engine. It's a subsystem of the SSH server. It's the SSH component that's responsible for encryption. SSH can encrypt lots of kinds of traffic, including telnet, file transfers, and just about any other kind of TCP traffic you want. SFTP simply is the add-on that makes file transfers more convenient to run through the SSH tunnel. Since SFTP is using SSH and SSH is already providing the compression integrity checking inherent in the encryption, SFTP is able to take full advantage of both. One of the biggest advantages of SFTP is that it is semi-ubiquitous. I say semi-ubiquitous because it's almost always available on Unix and Linux platforms. More recently, it's also been included as part of the z/OS base, and Windows 10 provides a client. You may have to install something on your platform to add the support. There are other free solutions in addition to the included support. There are also for-a-fee solutions. The free solutions will get you part of the way there, but there are usually some significant limitations involved. Base FTP does not provide EBCDIC to ASCII translation. Some of the SSH offerings available for ZOS have extensions to add this type of support, however. In addition, access to MVS datasets, the JES-Q, and other ZOS-specific features are usually desirable. Ability to offload encryption to the crypto processor is another feature that may be important. Fortunately, these other available for-a-fee solutions may in fact provide you what you're looking for, so you'll want to review what your needs are before deciding on the right solution for your environment. So what else do you need to be aware of? Well, the SFTP syntax is similar, but not the same as FTP, so there is a bit of re-educating that might be in order. Colin is going to provide another quick demo of SFTP usage and how it can protect your data. Over to you, Colin.
Thanks, Tim. I would like to show you a JCL sample that uses native SFTP command syntax. I'm sure the first thing you will notice is how different the command syntax is from regular FTP command syntax. And as Tim mentioned, there may be some re-education required if this is the route that you intend to go. So, if your end goal is to convert your FTP batch jobs to SFTP command syntax, then this is probably what your batch jobs would look like. Bear in mind though, that could be a huge undertaking from a resources point of view, and there are other alternatives that Tim will discuss in our demo that could make converting your batch FTP batch jobs to SFTP much easier. So this is the sample that I plan to use, and let me just point out, in the STS environment, we are not making use of OpenSSH, but we are making use of the SSH Tectia product that is taking care of all of the SSH encryption for us. Okay, back to the sample. In this batch job, I'm invoking the scp-g3 program from the bin directory. Now, there are a lot of different operands that can be coded within this batch job, but I try to keep it as simple as possible, and also time doesn't allow me to go into too many of the operands. The -q operand basically turns off some of the verbose information within the batch job. In this batch job, I've chosen to use password authentication, so that's the -- password equals, and the password is stored for this user ID is stored within this file or this PDS, and it is stored in bcvr1, that's my user ID, .password.sftp.sts. Password authentication method is the easiest to implement as it is set up by default, and since all communication is encrypted, passwords are not available for eavesdroppers. There are other forms of authentication, like server authentication with certificates is also supported, but the most popular form of authentication is user authentication with public keys in a file. There are automated procedures to accomplish user authentication with public keys by uploading the end user's public key and storing it in an authorized file. The File Transfer Advisor, or FT Advice string, tells the Tectia ZOS SFTP server exactly how to process and handle the file transfer. It is a lot like the site command, and the FT Advice string works the same no matter what platform the client runs on. Tim mentioned some implementations of SSH have limitation when it comes to the handling of converting data. SSH Tectia does not have this limitation, and in my example, the FT Advice string is instructing the SSH to convert EBCDIC data to ASCII as I'm sending from the mainframe to a Windows platform. The CRLF, or carriage return line feed line delimiters set by the I = DOS operand are converted to line feed characters, so that's the J = MVS, which are converted to new line characters in the code set conversion. One of the other limitations of OpenSSH implementations is the lack of native ZOS or MVS dataset support. My example that I'm showing you here at the moment is sending from the mainframe to a Windows platform, but let's assume I was sending from a Windows platform or Unix or Linux up to the mainframe. I could store the information that I'm sending up to the mainframe directly in an MVS dataset or ZOS dataset. There's no requirement to stage the dataset into a ZFS file system and then maybe use the ocopy command to copy it from the ZFS file system back into the Windows environment, the ZOS environment. So this gives you a basic idea on SFTP and the associated command syntax. When using SFTP, your user ID and data are all encrypted, although as Tim mentioned, once it reaches its destination, the data is unsecured and it could be a free-for-all again. I will demonstrate to you later how perhaps using data at rest encryption or PGP could be another option to consider. Tim, back to you.
As Colin has shown, SFTP can be a great way to secure your data. All the solutions we've discussed thus far are only designed to protect your data while in transit between sites, but once it reaches the other end, the data might be a free-for-all. Later, we'll be discussing some options if you're looking for more protection beyond transmission. If you're interested in disseminating data to your Linux farm or your partners that are using Linux or Unix, this might be a great option for you. What we hear from a lot of customers we talk to is that they've been told that they need to stop using FTP and start using SFTP, and that's about all the direction they've been given. If the real goal is encryption, any of the previous solutions should suffice, other than plain FTP, that is. If the goal truly is to implement SFTP, then this solution might be necessary. However, there may be another solution that will help make the conversion from FTP to SFTP more painless. I mentioned some for a fee solutions earlier that might make your job easier. The Tectia SSH solution provides a bit of a trick to build the bridge to ease the FTP to SFTP conversion. It involves an FTP to SFTP proxy. The FTP commands get routed to this proxy and are there converted from FTP commands to SFTP commands, allowing you to communicate with your partner's SSH SFTP server natively. The network portion is really SFTP, but your client jobs are really still using FTP. You just need to configure the FTP job steps to use the proxy. This can be done with a simple JCL modification. There are even other tools that can ease the JCL changes for you. Colin will give a brief overview of this solution in a bit. Just a reminder though that FTP and SFTP are not 100% compatible, so not everything can be handled automatically. But basic FTP functions generally make the transition pretty easily. Colin, over to you to show how this transition can be significantly eased.
Thanks, Tim. Okay, I would like to demonstrate two potential solutions to you. The first is using SSH Tectia to convert FTP to SFTP, and the second option is very similar but using a vendor solution to route batch jobs to a SOX proxy. First though, let's talk about SSH Tectia and the solution to convert FTP to SFTP. FTP to SFTP conversion is implemented using the Tectia SOX proxy component. So the Tectia SOX proxy is installed on one of my LPARs and I have it customized to do some of this conversion for me. The Tectia SOX proxy acts as a SOX proxy for the FTP client application on the Tectia server for IBM, the IBM ZOS host, and captures FTP connections based on filter rules. So there's a configuration dataset that you can go in and you can code up some of these filter rules saying or telling the proxy exactly what it is you want it to perform. The FTP connections are converted to SFTP transparently to the user and also to the FTP application. The only change needed in the FTP application is to change the SOX proxy setting to point to a local host listener. The SOX proxy uses the host name, the username, and password information provided by the FTP client application to open an authenticated and encrypted SFTP connection to a Secure Shell SFTP server. The Secure Shell SFTP server can also be defined in the filter rules, and this way the client's request for the FTP server destination can be overridden. So the following steps happen during the FTP to SFTP conversion. An application or a script or a user triggers a file transfer. The original FTP client in the file transfer client's host starts opening a file transfer connection to the original destination FTP server or the file transfer server. The FTP client makes a SOX query, and the SOX setting in the FTP client is set to point to the localhost Tectia SOX proxy instead of a real firewall. The filter rules that specify which connections to capture are defined in the SOX proxy configuration, and I'll show you that in a few minutes' time. The connections can be captured based on the destination, address, and or the port. The FTP to SFTP conversion module can extract the username, password, and also the destination hostname from the secured FTP application and use them for authentication and connection setup with a secure shell SFTP server. The FTP to SFTP conversion module manages the FTP connection so that it remains unchanged from the original FTP client's point of view, and the FTP is converted to secure SFTP file transfer. The SFTP connection is managed by the connection broker module, so that's software that comes with the SSH Tectia product, and the secure shell SFTP server in the file transfer server host is the endpoint of the transfer. The unsecured original FTP server program can be eliminated from the server host, so you don't need FTP running on there. Tim touched on this as one of the solutions if you're planning to use the solution where you can actually tunnel information across. Remember, Tim mentioned that there is a requirement to run an FTP server, and that's all definitions that you can set up in the SOX proxy. Okay, let's talk about the second solution, and this is the vendor solution I mentioned earlier. Pretty much similar to the one I just spoke about, but this one is using SSH Tectia with vital signs for FTP, or vftp as we commonly refer to it. So the concept is very similar to the previous solution I just discussed. The only exception is that the vftp client wraps around the standard IBM FTP client. This allows you to configure the vftp client to route batch jobs to the proxy. So in effect, the vftp client is being invoked as opposed to the IBM client. And I'll show you this in my demo in a minute or two. So what you could do is on vftp, you configure these batch jobs. When a filter rule matches the batch job, or you set up a batch job that matches something in the vftp database, that batch job will automatically be routed to the SOX proxy, where the SOX proxy will then convert it from FTP to SFTP. And the big thing to stress over here is you do not have to make any JCL changes. So if you have a significant investment in FTP, this might be the solution for you to consider, as you do not need to change your existing batch jobs, or you don't have to take that huge undertaking to convert all of those batch jobs from FTP to SFTP. Let me provide you with a quick demo of the solution. And what I'm going to do now is just talk briefly about the VFTP or the SOX proxy configuration. So this is the configuration that you would use on the SOX proxy, and you can configure the proxy to do various different things. The IP address, that specifies the target host or the IP address to be filtered. We've got a bunch of test connections here, and I'll show you the last one, which we call the catch-all, which might be something, or the end goal for most customers to maybe want to send all batch jobs from the mainframe to a SOX proxy. The port attribute specifies the port to be filtered. It can be a single port or a range. Okay, so this is pretty important. The action attribute specifies the action to be performed when a filter is used. For FTP to SFTP conversion, the action is set to FTP proxy. For transparent FTP tunneling, the action is set to FTP tunnel. So I think I do have one of those settings further down. There you can see on this particular connection, I've chosen to use FTP tunneling. Remember, with FTP proxy, you don't need a remote FTP server, whereas with tunneling, there is a requirement to run the FTP server. The username from app attribute defines whether the FTP tunneling or FTP-SFTP conversion extracts the username sent from the data sent by the application. And then lastly, the hostname from app attribute defines whether SOX proxy should extract the secure shell server hostname from the data sent by the application. Okay, so this is the SOX proxy configuration. I've got the SOX proxy up and running in my environment. Let me show you that quickly. This is the SOX proxy starter task. We've got a few of them running on our system, but it's running and it is already configured to trap some jobs and convert them from FTP to SFTP. So what I would like to do is now show you the vendor solution with VFTP. I've logged onto VFTP. This is the user interface. It gives you complete visibility on all of your FTPs. With our VFTP client in play, you can see the context of FTP transfers. You can see now I've said for the last 8 hours, show me all of the FTPs of all of the agents that's reporting to the server. There you can see there's some using FTP to SFTP conversion, bulk of them using unsecured and some using SSH. By clicking on those numerics, I can go and view each of those FTP transfers and view them independently and also see the session log for it. Okay, so what I want to do is to show you how the product works. I'm going to click on the configuration tab. Let's go to the client. And now in fact, we've got a bunch of different rules that do, various different tasks. I'm going to select one called FTP SFTP3, and that is enforced only on an LPAR called STS1 or an agent called STS1. It's set up for a job name, so this is the filter rule. It's set up for any batch job that matches ZFTP job star. So it could be job 1 through to 9 or ABC, whatever, anything that matches this filter rule. VFTP will intercept that FTP and it'll route it to the SOX proxy, and the proxy will then convert it to SFTP. You do not have to make any changes to your JCL, and I'll show you that in a second or two again. There are some additional operands that need to be added to your FTP.data. In my example, I've chosen to use a new one, but you can just put it into your existing FTP.data. That way you don't have to make any JCL changes. And then importantly, sessions for this job step must run across a SOX proxy. So I'm ready. I can now go and submit this batch job, and let's go and have a look. So I'm going to switch back to TSO and go to, there's a batch job, ZFTP job. As you can see, it is regular FTP command syntax, doing a CD, doing a binary transfer, and then doing a put of a file. So let's run this particular batch job. And let's swap. Let's go back to STSF and let's do a prefix of ZF. Let's go and examine the contents of this. Looks like it's already ended. And let me go back down and just point out some of this information. It's a very small batch job, so ran very quickly. There you can see the job name, ZFTP job, and it's applying the rule that I set up on my VFTP client. So you remember I pointed that out to you. And without me having to do anything, the proxy got in, without me having to make any changes to my JCL, the proxy got involved. The proxy converted the batch job or the FTP to SFTP, and I didn't have to make any changes to my existing batch job. So that's the beauty of the solution. As I mentioned earlier, if you have a big investment in FTP, this is probably a solution that you want to consider. And then lastly, just to show you, let's go and get some information perhaps for the last 30 minutes and let it get button. All of this information can now be viewed on the UI, and there's my user ID. Let's get the log data. So similarly, you saw this on STSF, but this is because our VFTP client is in play. You can now view the context of this FTP transfer. So the exact same information you saw on STSF. Okay, so that was a very quick demo. I know there's a lot of ground I covered there, but certainly if you need more information, feel free to reach out to us and we can assist you with providing you with more detail. Tim, I'm going to hand back to you now.
All right, thanks, Colin. So if you have a big investment in FTP in place and a conversion to native SFTP will be a major undertaking, this might be the best solution for you. I mentioned that I'd also be discussing some other technologies you might be able to leverage. VPNs might already be in place to allow you to get your data transferred from one site to another safely. If it's already there and it's satisfying the need, you probably wouldn't be listening to this webinar though. I wanted to simply mention it because it might play a part in your overall strategy. VPNs are commonly set up between two networks to encrypt all the data between them. They are also commonly used between the network and a host, perhaps from a home office environment. VPNs provide lots of flexibility in what you can get access to, but easy access also means either more administration or less control. But it can be a great solution for the right problem. Since VPNs encrypt data, integrity is a usual good side effect. Also, some VPN software can provide compression. It's not always there, however. Since VPNs are implemented at a lower level of the IP stack, applications don't really need to make any special accommodations for the encryption. Unfortunately, VPNs are not usually a good choice for ad hoc connections. If you need to make occasional secure connections to some of your partners, one of the other technologies might be a better choice for that. In addition, when a VPN is implemented at the firewall, that's where the encryption ends. Traffic over the intranet is unprotected. I discussed that concern earlier. I'm not sure if this is a pro or a con, but VPNs are generally managed by the network group, so it might be something that can be offloaded, or it might be something that's outside your control. It kind of depends on your point of view as to whether that's a good thing or a bad thing. Okay, I said that I'd talk a bit about data at rest as well. So there is one more solution that I'd like to review. It's different than everything else we've discussed and can be a really good option, particularly when the data involved is of a highly confidential nature. If you pre-encrypt the data, it'll be protected in transit, but it's also protected at the destination. Only those with the proper credentials can extract the data. Since encryption is already handled, any transport will do. As a matter of fact, good old FTP might be a good choice again. If you go that route though, remember that the authentication of the FTP control session would be plain text again. But since the data is already encrypted and can be protected by access at the other end by requiring the proper credentials after transfer, an anonymous FTP session might be used safely again to transmit the data and still protect it from prying eyes anywhere along its path. PGP also provides the compression and integrity that can be so important, particularly in large files. But another thing you might consider is that PGP isn't just for network transfers. It can be used even if the data doesn't move at all. For example, you might encrypt the file for archival and delete the original. Just make sure you keep track of the necessary credentials to decrypt the file, or you might be in trouble later when you need to get back to the data. Oh yeah, and what about those little USB thumb drives? Well, if the data was encrypted on the thumb drive and it gets misplaced, you'll still be able to sleep at night. The pre-encrypting, though, means that the data does need to go through a bit of staging. But once you've introduced it into your batch jobs and processes, that step can be transparent as anything else. So as I mentioned, this can be a really good solution when you're concerned about more than just prying eyes on the internet. Back to you, Colin, to demonstrate how simple and effective this can be.
Thanks, Tim. Let me kick things off by providing you with a brief overview of encryption basics. I'm using a product called eBusiness Server to encrypt the data on the mainframe, and this product is based on the Open PGP standard and allows you to exchange data with any other PGP product that adheres to the RFC standard. It is based on a widely accepted and highly trusted public key encryption system in which two complementary keys called a key pair are used to maintain secure communications. One of the keys is designated as a private key to which only you have access, and the other is a public key which you freely exchange with other users. Both your private and your public keys are stored in keyring files. As its name implies, only you have access to your private key, but in order to correspond with other users, you need a copy of their public key and they need a copy of yours. You use your private key to sign the files and attachments you send to others and to decrypt the messages and files that they send to you. Conversely, you use the public keys of others to send them encrypted data and also to verify their digital signatures. Okay, so that's a brief overview of the basics of encryption. Let me show you how you can use eBusiness Server to encrypt data on the mainframe. Remember, eBusiness Server is multi-platform, and as Tim mentioned, you can use it to secure any type of data, not only data that you'll be sending to your business partners, but any data that is at rest. So here is a sample batch job that is encrypting a very small file. Tim mentioned this also in his part of the presentation, where you would probably need to include this step into your batch job prior to you sending out the data or the ciphertext to your business partner. In this sample, I'm encrypting the contents of the data in this file over here, and that is going to be the ciphertext. So that'll be the file that I send to my remote business partner. There are many different ciphers available and supported on eBusiness Server, but this is just a brief example of what I'm planning to do here. So let me show you what the input file looks like. And you'll see it's just a very small file, just showing that this is what I'm planning to encrypt and the data that I'll be sending to my business partner. After running the job, so I'll submit that job quickly, and we'll then go and examine the output, which is going to be contained in this file over here. So let me grab this file, and we can go and have a look at the contents of what the ciphertext looks like. So there you go. This is ciphertext. This is not anything that somebody can eavesdrop on or make sense of, and this is typically the information that you would send across to your business partner. So very simple example of how you can actually use PGP or eBusiness Server to encrypt data. And as Tim mentioned, there's various different options available to you. But if this is one way that you want to secure data and you want to send it to your business partner, you could certainly consider using regular FTP or even SFTP, depending on what your requirement is. So that's it from me. Tim, I'm going to hand back to you so you can wrap up the session. And thanks everyone for your time.
So, PGP can be useful even when network transfers aren't involved. But in some cases, the network is involved, but controlling the network is outside your domain. Firewall admins can sometimes be a little finicky about allowing traffic they're not comfortable with, or they might have other tasks that are of a higher priority than yours, at least in their eyes. Since PGP can be used over any transport, you can take back control of your data. Before I wrap up, a couple of other items you might consider for securing important data beyond what we've discussed. Off-site backups and obsolete hardware are a significant concern in the big picture. I won't be going into any depth here, but encryption of data within an environment can be done transparently to the end user as long as access to that data occurs within that environment. But if the data is removed from that bubble, the data can be protected from unauthorized usage. Encryption of data on disk and tape media can be a good solution here. At the cost of some CPU cycles, which are getting cheaper every day, that additional assurance can be of great value. So, hopefully this mess isn't quite as confusing anymore. We discussed lots of possibilities, and the reality is that it's not that likely that any one of these solutions will solve all your needs. You'll probably come up with a mixture of different solutions. Finding the right technical partners to help identify the problems and what solutions fit your specific puzzle best can save you lots of time and your company lots of money. SDS is here to help you to get a grip on your particular onion. We can provide you with the expertise and tools to help you get the job done. I think we have a bit of time for some questions, so let's go back to the moderator and see what we've got.
All right, so we have a couple minutes for questions. Here's the first one. How much time and work would it take to implement the SFTP options?
Thank you, Casey. I'll take that one. I suppose the answer I would say depends on the route you choose. Obviously, you've been presented with a number of solutions today. However, if your plan is to implement native SFTP and do a complete rewrite of your batch jobs and scripts, then I would say it's going to be a pretty long process and a significant effort from your production support team. And also the team, I think, that would be migrating your SFTP to the distributed platforms. You may remember in Tim's presentation, he spoke about re-education required for folks if SFTP is the option you choose because the command syntax is very different. So I would say this could be quite a long undertaking for customers depending on the amount of resources they allocate to this project. However, the other solution we spoke about, if you go the proxy route, we do not have to change your batch jobs and the proxy does the conversion for you. I would say the rollout time would be significantly less. There is still some work required though, exchanging and uploading of public keys, but once these tasks have been completed, it's just a matter of you identifying the batch jobs you want to migrate, testing them, and then rolling them out to production. So I would say the effort when going the proxy route is a lot less and a lot more painless.
Great. I think we have time for one more question. We're concerned about having to rewrite scripts that have been in place for decades, primarily JCL, in process of securing FTP. Which secure options will let us continue using scripts?
Yeah, that's a common problem. In fact, Deb and I have conversations with customers on a daily basis, and we hear this all the time where these legacy FTP batch jobs are in play and people don't have any clear direction as to what they want to do. But there's a number of options, and I would say it's not a one-size-fits-all. I would recommend a one-on-one discussion, but off the top of my head, I would say definitely the proxy route because there's going to be definitely a lot more less intervention, not a lot of changes required in order to go that route. So that, in my estimation, would be the route that customers would go if they do not want to make a lot of changes to the existing scripts.
All right, well, thank you. Any questions we didn't get to will be posted alongside the recording. That concludes today's webinar. We'd like to thank everyone, especially Colin Vandeross and Tim Full and the Software Diversified Services team for attending the event today. This feature will soon be available on the SHARE website at share.org. There is a survey after this webinar for you to complete, and we thank you in advance for your feedback. Thank you again for attending today's webinar, and have a great day.